Cool. Okay. Hey, today, if you have your notes out, here's the challenge we're going to do today. We're still going to continue this because I think it's important that we keep reviewing that because that's what your latest homework is based on that you're going to get today. But I want to do one extra part of it today, and this is not something that I'm expecting you to do in your homework, but I want you to see a tie into something we've learned previously. I kind of hinted at the fact we're going to be doing this, and today is your first attempt. Now, it will require, for this to work out, it will require that you know either the quadratic formula very, very well, which is that negative b plus minus square root thing, or you need to know how to factor very well. Okay, that's what we're going to be looking at. Okay, I'm going to put an example on the board, and I'm going to explain what we have here. So here's what I'd like you to do. In your little group or pod, if you're by yourself, you can move to another group. I'm going to put a problem on the board, and I want you to go through the parts and knowing like what each of these pieces are. And then once I give you enough time to get settled in, you know your problem pretty well, we're going to talk about the main portion what I want. So here's your example today. All right. X cubed minus 2x squared plus 8x and 16. Okay, I'd like you to write this problem down. This is our function today. This is going to be our kind of our go-to problem. We're going to look at all these different pieces today. It's very, very, very similar to the problem I did yesterday, on Tuesday, I should say. This is to hopefully get us in that right frame of mind so you know how to do your homework today. So I think it's kind of important that we do a tie-in plus, something new. Today is no joke. This is probably the most challenging stuff you're going to see for a while. The other stuff we're going to be eventually doing, we'll get up to this level again, but today is kind of one of those days you need a challenge.
What is that? No, we need the leading coefficient is factor. So it's 1x. So it's positive. So it's factor hour. So they go off to the third. You can't take it.
Oh, you have to group your group and do things. Obviously, you have to do that. Final three. You fresh guy, so
Yeah, you're good.
What do you
Not that.
Okay.
Alright, so, hey, what I'd like you to do, let's figure out the pieces of it. Let's figure out, end behavior, figure out, the leading coefficient test with that, figure out x-intercepts, if we can, figure out the multiplicity test, any y-intercepts. We're going to talk about a couple different things here, but I think it's important that we look at some different stuff. So this is kind of our challenge problem today. I want to see how well we can do with this. So, any group know the first part. Leading coefficient test, end behavior. What do we have? Okay. So, Billings, what do we got?
They go one down and then the other goes up.
Okay, what side would this be on?
Bottom.
Bottom half? Okay. Okay.
So
And the other half would be, which over here? Top. Okay. I agree with that. Why? You're right.
because it's positive and an odd power.
Exactly. It's a positive number, so this is a normal graph, and it's an odd power, so they have to go different directions. And that's what a normal graph looks like for an odd power. Does that make sense? That was excellent. Okay. Now, that covers the first two. That's leading coefficient test and end behavior. It covers both, the first number and the power. We looked at both things. I just put them together usually. X-intercepts now. Anyone happen to know what the x-intercepts are or what we need to do to find them? Run over it again.
Is it negative 8 and positive 2?
Okay, so let's talk about how do you find it? How do you what do you do to this problem?
You gotta factor it.
Okay, so how do you factor it?
Well, you can take x squared out of x to the third power minus 2x.
Okay, x squared coming out, so that's x minus 2.
And then you can take 8 out of 8x minus 16.
Okay. Like that? Now what?
You take x squared plus 8 and then put that in parentheses. And then you put x minus 2 right next to it.
Okay. Now, here's the weird thing. Okay, you said our x-intercepts earlier. What was
Yeah,
it?
that's probably wrong.
No, sit. What did you say?
Negative 8, positive 2.
Okay. This is what we were saying.
You factor
One of
that
these is correct.
in. Positive.
Positive 2 is. Okay? Now the reason why. If I were to plug a negative 8 in here, you'd square it, making it 64, and then you have to add it to 8, that doesn't make 0. Because it's x squared plus 8. Right? So it can't be negative 8. That part right there in that parenthesis has no x-intercept. The reason why there's literally no number you can plug in here that will make 0. Because no matter if you even plug negatives in there, when you square it, they turn positive and you add them to 8. If you plug a 0, which is basically the smallest value you can get, if you plug a 0 in here, you get 8 out of it. You'll never make 0. It is not possible to make this parenthesis 0. So this one has no roots. So the hard part about this is that, I think this is one that I hinted at on Tuesday, is that this problem really only has one x-intercept. And that really throws people off, because when you look at the problem, like one of the hints I told you, on Monday and Tuesday was that this problem should have 3. It's a power of 3, so it should hit the x-axis 3 times in theory. But what happened here is that we're going to look at this a little bit. It's been shifted down 16. That's like a translation. It's been shifted vertically down 16. So it never actually touches the x-intercept 3 times. What's happening is that it's going to hit positive 2. I agreed with that one. But the graph, it's kind of going up and down kind of thing, but it's doing it down here, where it never actually hits the x-axis like 3 distinct times, because it's too far low. If that 16 would have been different, like if they didn't shift it down so far, yeah, it possibly would have hit 3 times, 1, 2, and 3, but it didn't. And that's what really throws people off, is that they just don't see that. I don't know if we even talked about a problem like that on Tuesday. It was one of those things we had to discuss. Okay, questions with that?
Why can't you factor the x squared?
Okay, it's not a difference of squares. It doesn't have a minus sign, right? So if it had a negative sign, yeah, you could go plus minus, break up the 8 evenly, so you'd have to do square root of 8, x and x, right? But it's a plus, so it's not a trinomial rule, it's not a difference of squares, it's not a cube rule, so yeah, there's no factoring to it, which is tough. And the other thing is, like, if you just do the old school thing where you just set equal to 0 to solve it, because that's what some people do, they set equal to 0, and you subtract this over, it literally shows you that there's no solution. Like right here, you can stop. There's no way you can square a number and get negative 8. Like there's no way. It's not possible. It would be imaginary numbers. Because when you take the square root to the other side, you get the square root of a negative number, which doesn't work. So it didn't matter. So that's another reason. Okay, are we good with the first step? You needed to see that. I don't know if I talked about one on Tuesday, if I talked about one on Monday. It was just something we had to discuss. I know my period 9 class they have seen one, because it was just one of the examples that we created, but I thought we had to get you guys to see one of those, so that you didn't have to hit 3 times. Okay, we're good so far. Okay, let's keep going. So we're done with that. Multiplicity test, we look at, are we passing through, are we bouncing off? So we have to look at the parentheses. Okay, the powers on the outside, what are the powers on this parenthesis? So 1, well that didn't have any roots anyway, so it doesn't matter what's the power on this one. 1, so since it's an odd power on that parenthesis, that means we're going to pass through this number, and that makes sense for the graph. That eventually, it's doing something probably down here, and it's going to pass through, and the arrow will continue up. So it's kind of going with where my end of your arrows are facing. So if it bounced off of that, it would be going down, and the arrows would be going the wrong direction. Okay, let's do y-intercept. What do we get? Negative 16. Okay, most people just know by looking at this problem. The trick is you plug in a bunch of zeros and you get negative 16 out of that thing. So it's way down here, and that's kind of what I was kind of warning you of, that it's been shifted so far down that it's doing something down here like this. This is pretty much what it's looking like, and it's going to go through this spot and keep going. Okay, now I'm greatly exaggerating the curves here, but I want you to see that. And I have no idea where those those bends are. I don't even know if it turns around at negative 16, maybe it goes further down below that. I'm just showing that kind of step. Okay, we did y-intercept symmetry. Is this thing symmetric? Definitely not. The reason why, the x-intercepts aren't balanced. For something to be symmetric, if they have x-intercepts, they have the same x-intercepts on both sides. So that's kind of a red flag. The other thing is, if it's not, if it doesn't have the same y-intercepts or x-intercepts, maybe it doesn't have any, because maybe it's doing something like this where it's kind of going down. But the pictures still have to look the same on each side for it to be symmetric, or it has to pass through the origin if you want to be odd symmetric. My little rule for symmetry, like this is my personal rule, this is not what the book says. You look at all the powers, and you look at like the powers, and you see, are they all even powers? They all odd powers, because that's the type of symmetry. Are they all even powers? No, it's like a 3, a 2, and a 1. They're like going even, odd, even, odd. So it's not, they're not all evens, they're not all odd powers on all the variables, because even this last one has a 0, so like it's a mixed bag of even and odd, so this is not symmetric. For it to be odd, they just have to be odd powers and no number at the end. If it's even, we can have all even powers with the number at the end. So that's how I can kind of check. That's my personal rule that I do. The rule that the book says, you plug in negative x's and everything, you simplify and you try to see, does it turn it back into the original thing, so it would be perfectly balanced then. But my little rule is you just kind of look, x-intercepts are a red flag. Turning points. How many turning points should this thing have? We talked about this on, say it, should have 2. We talked about this on Tuesday, that you always take the greatest power and you subtract 1 off of it. And that will give you how many times this thing will turn directions from its original path as you go left, right. Its original path was like climbing. Then it changed directions once, twice, and that's what should happen. And how I know like what this graph should roughly look like, if it has all the variables accounted for, typically if it has all variables accounted for, this thing should be going up and down, right? It should oscillate a couple times. If a couple of the variables are missing, let's say I'm missing 8x, or I'm missing like both of these terms, and like I just had x cubed minus 16. Well, then the idea is that it's probably really smooth. It's not doing such a dramatic turn up and down. All right, questions at all about that? All right, now, I know this is a different look to your other problems. It's more difficult because we can't see what it's doing. It's just one of those things that's not like, a lot of you might think it's not difficult at all, which is great. But the problem is, we have not discussed one thing, and I hinted at the fact I want to show you today, and this is the only thing I want to talk about today. It's one problem, it's going to take a lot of marker board space, even though this is roughly what the graphs look like. In fact, I'll pull it up here, I'll pull up my actual graphing program on my Mac, and we'll take a look at what this thing looks like so you can get a feel for that. Does that make sense? Okay, the one thing I want to do today on the marker board, and I want you guys to see this for the first time, is where are these peaks and valleys? Where's that dot going to be? Where's that like relative maximum, the hilltop? And where is this relative minimum at? Because I have no idea. Like I'm making that up. I have no idea where the curve is. Okay, I just know that it's hitting a y-intercept of negative 16. It's hitting an x-intercept of 2. That's the only thing I really know. And that's what I want to show you today. That's incredibly hard material. Like it's difficult when you see it for the first time. And it's going to take a lot of marker board space. But let's draw this so we can get a look and feel like, is my graph roughly correct? Okay? Okay, we're good so far? Now, this is not something I expect in the homework, but you need to see it. It's one of those things, it's a tie-in to what we did last chapter, to this chapter, and how we fit everything together, so it makes sense. Okay? All right, let me graph this thing. I'm going to get rid of this graph. Let me pull the grapher program. Boom. All right, here we go. All right, I'm going to type in my problem. So x to the third power, that's x, the shift 6, give me a little caret, put a 3 up there, then I have to hit back so it gets out of the power. I'm going to subtract x squared, we get out of the power, so I have to hit the arrow key, plus 8x minus 16. Hit enter, and let me zoom out so we can get a feel for where this thing is going. Oh, yeah, a little hand tool. Zoom out. Zoom in here. Let's see what this thing is doing. So it doesn't look like it's, so it looks like it's a straight line. I wonder if it's curving later. No, okay, so this one's incredibly smooth, the way that's gonna work, so this will save us time, so we don't have to work on this one. Okay, as you can tell, what this thing is doing, it doesn't look like it's oscillating so like violently up and down. This one is appearing that it's just doing the normal x cubed graph, where it's doing something like this. Okay, it's not going violently up and down like our previous problems have, where they've done something like this. Or they've really spiked and they've hit peaks and valleys. So this will save us time by looking at that. I won't put us through the math just to figure out that it doesn't have an answer. On this next one. All right, questions at all about the graph itself? Okay, everything went correct. The only thing that was different was it doesn't have its crazy peaks and valleys, just because of the way the numbers fell probably. And the fact that another thing is because it didn't have another imaginary root. That's probably what threw this thing off. Okay, let's do another one. Let's do one where it actually has peaks and valleys. So I'm going to make the new one. Let's type this. Let's write this problem down, but I'm just going to do all the steps for you really quick because I need to make sure that we actually have peaks and valleys to show you the math here. Okay. I'm going to do it for kind of an easier problem. Okay, and this can be any type of polynomial. Let's go with, I'm going to go kind of an easier problem. This will make it a little bit simpler to look at. Let's go with x squared minus 10x plus 9. This will be my function. Okay, so it's a square, so it is a curve. Where are the tails ending up at on this particular picture?
Both going up.
Both going up. They're going in the same direction. Okay. Because it's positive out front, so we know that it's going to be a normal graph. It's got a 2, so the tails have to go the same direction, and so they'll end up going up wherever they're at. Okay. I'm going to factor this thing apart because that's the end behavior we already know they're going. Factoring this thing apart, this one's pretty straightforward. It's going to be x minus, because they're the same, they're both negatives. It's 9 and 1, that makes the 10 in the middle. So where are my x-intercepts at?
Line and one.
Good. Positive 9, positive 1. I'm pointing at you guys. All right. So looks like we're hitting at 1. We're hitting at 9 way down the road. So it looks like my tails are going to be like over here. The powers on those parentheses to do the multiplicity test, they're both 1s. So it looks like it is passing through those numbers, and that makes sense for where my arrows are facing. That it's passing through, it's turning around at some point and coming back up. Here's the focus that we need to work on today. Where is that valley? Where is that low point? Where is it hitting? Where's the dot? Now there's going to be multiple ways of doing this throughout the year. This is the first way I want you to see it, and it's the way that we do it in Calc 1. So it's like a Calc 1 problem I'm throwing at you for the first time. You know, this is pre-calc. I'm trying to get you ready for that level so you can see why we do it. Now, y-intercepts, let's do that one next. It's going to hit positive 9. So my drawing's a little bit off. It's going to hit positive 9. Terrible. All right, there you go. It's hit positive 9. The reason why, if you plug in a bunch of zeros, you get 9 out of the thing, so it does have a y-intercept. Symmetry, definitely not symmetric. The x-intercepts tell me it's not symmetric, it's not balanced. And turning points, it should turn once. You take the biggest power, you subtract 1 off of it, so it should turn in one direction. So it was going down at first, and then it turned directions, and it ended up going up. So it did turn in one direction. Now, to find the turning point, when did it actually change? That's what the math is involved here. Okay, so does everyone have this problem written down? I'm going to start and stop the camera so we have everything of this on film, because you're going to need to see it. All right. What we're going to do here is called the differential quotient. It's what we did in the last chapter test. It was problem number 5 on the test. It was doing this, if you don't remember it. Does everyone remember that formula what we did? Okay, I'm going to set this problem up, we're going to do it. And the good thing is that I picked kind of an easier problem so we don't have to do so much math. You're going to see for the first time, why do we even have have that rule. Like, what is it? Because I didn't really warn you what it was. I just said it was like an average slope, and you do it for any function. Now you're actually seeing the purpose of it. It's for this graph to figure out where is this dot right there. No joke, that's what it's used for. It's one of the hardest things to actually do. In fact, they spent an entire semester in Calc 1 going over what this thing is. No joke. Calc 1 is that for an entire semester in college, and it's brutally hard. And I'm going to try to teach you in about 5 minutes how to do it. So, doing the differential quotient. Okay? It's taking this thing first, so I'm just going to do this part right here. This part right here, where I'm plugging the x plus h in for that thing. The whole function with x plus h is plugged in. So this is x plus h squared minus 10 times x plus h plus 9, right? That's the function with x plus h is all plugged in. Agreed? Wherever there's an x plus h. Then we're going to subtract, I'll try to color code this so you can see this. We're going to subtract the original function off. So we're going to subtract, in parentheses here, the x squared minus 10x plus 9. And this is all going to be over h. There's the setup for what we need to do. Now, I said this is tough, because now we have to simplify, and we have to do a couple extra rules to see how is it going to work. Okay? And this is the challenging part. Okay, this thing right here, when we simplify this thing, we actually like FOIL it all out. What do we have to do? Because you can't just distribute the 2. So what does this mean?
You have to factor.
You have to not just
Not
factor.
factor.
FOIL
That's what I
it, so that means I need 2 parentheses, and then you multiply them together. So first, outer and last. I'm going to do this in my head, sorry. I'm going to try to keep it color-coded so you know which part I'm working on. Okay, so I'm going to put it up here, because we have a couple more lines of work. This is going to get long and lengthy and tedious. Okay, so foiling this out in my head. So it's getting 2 parentheses, x plus h times x plus h, and actually multiplying together. It's x squared plus 2xh's plus h squared. That's doing 2 of them back to back, foiling like x times h times h times x, and h times h. That's that thing. Then I'm going to distribute this negative 10 to this part. So I have negative 10x minus 10h. Then I have the 9. Okay, so there's all the parts in green. Make sense? I said this takes a while. Now on the back, what do I have to do with this negative sign? Yeah, it distributes it all to the back, so everything will become the opposite. So this can be a negative x squared, positive 10x, negative 9. And this is all over h. Again, this is supposed to show you the tie to what we did in the last chapter to this chapter, why we do those things. Okay, what I warned you of in the last chapter, if you're doing this correctly, what should go away on the top of your fraction? Everything without an h. That's how you know you're doing it correctly. So, in fact, when we see this, the x squares are gone. Boom. The 9s are gone. The 10x's are gone. So everything without an h did go away. So here's what I'm left with. I'm going to write this down. I'm left with 2xh plus h squared minus 10h. And this is all over h. And that's the answer I was looking for on the chapter test. That's what we're going for. Now, to go further, here's what we use it for. First step, you have to divide everything by h. So, because the h is on the bottom, right? So you can divide everything by h's. So this is a rule of division. It's a law of division that you can divide everything by h since they're all on the top. So that's 2x plus 1h minus 10. So you can divide everything by h. Make sense? You can do that. I know some people actually went further and actually did that in their chapter test, which is good. That's kind of something you should know how to do. But here's what I didn't tell you, is what we do with this thing when you're done. What this thing does is, what you're supposed to do is make, this is called a limit. It's a limit, what I'm about to show you. A limit is you approximate. Okay, it's approximation. It's the limit as h eventually approaches 0. And I'll show you why that is. For this problem, like what you just ended up getting. As h approaches 0, what does this formula turn into if h was eventually turning into a 0? What do I get? As h turns into 0, what would this thing turn into?
2x minus 10.
Perfect. Okay, now, why we do this? This is huge. Write that down. We need to have that part. Okay. Why h is turning into 0? H is that mystery number where what this whole thing was set up to be, it was set up to be sloped. That there was a difference in x's, or sorry, difference in y's on the top. These are y functions. And on the bottom, it was this. It was x plus h minus x. This was on the bottom. And when you subtract, you get h. That's where it comes from. Because what you're doing on a graph is you're getting closer and closer to where two x numbers are insanely close together on a graph. And the idea is that I'm actually picking x's that are so insanely close that the only difference between them is like a little h gap. Like where h is literally almost 0, where the two dots are almost right next to each other. So as h approaches 0, as you get closer and closer to 0, where there's literally no gap between the two dots, what's going to happen here is it's going to point right at the dot at the bottom of the curve. That's what I'm looking for. Okay, so I'm looking for the exact moment where the dot is there. So what you do is what number makes this thing 0? It's like another x-intercept. You're looking at that number. So what would make this thing 0? 5. This number right here, what you just found, is the spot where the graph turned directions. It did that turning point, going from down to up, right here at 5. Like I almost knew where it was going to be. It's crazy. Make sense?
Wait, so the x is...
The x is 5. To find the y number where it's at, that's the part that I didn't draw correctly. It's like, where would that spot actually be? Where would that, it's 5 over, but how far up and down is it? That number, to figure that out, you take your 5 and you plug it back in, and that will tell you the y number. Because now you're actually evaluating the function where you know your x is 5. And if you were to plug 5 into this mess, you're to take 5 and actually plug it in, it would tell you the y number on that graph. So let's plug in 5. So 5 squared, 10 times 5 plus 9. And again, my drawing is definitely not correct. I knew where the 5 was, I just didn't know how up and down it was going to be. So this is 25 minus 50 plus 9. So this is negative 25 plus 9, which is, negative 16? Yikes. That's way down the road. So it's way down here. Now, most people can figure out there's a shortcut. There's a shortcut when it's an easy graph like that. That it's, how I knew where the middle was going to be, it's the dot right between your two x-intercepts. So when it's an easy graph, it wasn't some mystery number. If this is 9 and this is 1, all I have to do is go the number that's in between them perfectly. Well, the number is 5, right? Because that's exactly 4 steps away, that's exactly 4 steps away. I knew that going into it. That's kind of the shortcut. But when you're on a bigger graph, like one that's like an x cubed graph, where it's going up and down, oscillating more than once, just like not just turning directions once, now you don't have that luxury anymore. Where now you have to go find those numbers using this whole process, that differential quotient. And the differential quotient will require that you know quadratic formula and factoring, all that good stuff.
So in Calc 1, in
Yes.
college, when they spend a semester on this, are
Yes.
they just doing it with like ridiculously hard problems?
Yeah,
or what?
ridiculously hard problems, like crazy curves. They're doing it for story problems and looking at, like max and min values. Like there is a story problem to that, where you're looking at the minimum value for your sales, like where are you going to lose the most money, which month would it happen. So they try to apply it to everything. That's the hardest part about Calc 1, is that they teach you this concept, right? They teach you this and they do it over a whole semester, but then what they do is over that whole semester is they show you what you can use it for. And they get harder and harder and harder until it just like breaks you eventually, or you just can't figure it out anymore. And it's one of those things like once you have it figured out, like the concept, it's not difficult. Like it's not. But you have to get set up right, you have to get the formula down, you have to know what is it doing, like what's the overall broad view of it. Once you have that, you're fine. You just have to back up, because you get so lost in like, oh my god, these math problems are so difficult. You just have to take a step back and like, it's not really difficult to do it, but to apply it can be. So, like, just showing you like what I did, like that little common sense, like it's the number in the middle. Like once you see that on a certain easy problem, you're like, okay, well that makes sense now. Like I can understand that. Well, now you have one piece of it. Now when you do it for a bigger problem, now you have to think about all the complexities of it. But I wanted to show you that today. I think it's important that you get to see the tie-in. You get to see a real life example. You have to in calc and you have to do it a lot. All right, now, is that something I'm gonna require you? No, but I think it's important that you get to see that we can find those peaks and valleys for max and mins. But it's all the stuff I've been teaching you, just you have to shove it all together and make sure that it meshes. Okay, here's your homework today. And homework today is not this, it's doing all this stuff you're drawing. Your drawings, I'm gonna give you graph paper for this today. You just have to be roughly approximate like what you think it's going to look like. Okay, you have to have the x-intercepts correct, the y-intercepts correct, but then the graph can be off. Like you don't need to use Desmos. You just have to give me that rough graph. Like I drew that graph earlier, my graph wasn't even close to what the real graph was, but I knew roughly what it was going to do. You know, I knew it was hitting a certain x-intercept, a certain y-intercept. I knew all this other stuff, and that's what you're doing. So, just make sure you're taking time on this, okay? All right, here's your homework. This is going to be due on Monday. It'll be due Monday. Now tomorrow, we're going on to the next couple sections. So I thought this was kind of important that you guys get to see this. Okay, pre-calc, here we go. It's page 312. Numbers. These are all evens, by the way. It's 42 through 52 evens.
Are they all graphing?
Yeah, there's exactly 12. 56 through 64 evens. Now, if it doesn't, like, if the numbers are huge, let's say like the x-intercept was negative 29, just put it at the bottom of the graph, like I do. Like, you don't have to be super accurate. You're just trying to get a rough sense of where this thing is going, what it's going to look like. Okay, if you need to change the scale, you can change scales on pictures. Okay, so maybe you want to go by 10s or by 2s so that it works out. I don't know how you want to do yours. So, but I need to give you graph paper, but that's it. As you guys are working today, because you have about 5-6 minutes here, you want to get started on the first one, get a sense of it. You can do that. I'm going to hand out graph paper. Use pencil, 1 graph per problem. Does that make sense? I counted, there's exactly 12. 1 graph per problem. There's 2 there, I think.
Not gonna do it all. I'm gonna use.
Oh, yeah, this is one.
I think we could look at Bryce and see all the red marks.
Okay, so, I have a question, it's just off the top of my head.
Okay.
Can you give me, like a formula similar to the one that we had last week? Yeah,
Okay. You want a square graph, you want a cube, you want something bigger?
Reflexive. Skip.
What's that?
50.
Is that
The square.
Square graph,
Okay.
Wow.
X squared plus 7x
I'm actually gonna have my dad.
plus 10.
My dog has it.
Okay, so, couldn't I
I
technically?
mean, he's adopted, so that's probably.
How do you know that yet?
He told me. Idiot.
Can you remember when it was
Is that going through the whole process of doing that, and would that be right?
No.
Hmm.
It'd be very, very close.
Then would it be,
Happy November.
that be right there?
After 11, 1, 18. Can you guys believe this?
But I-
This is the first time it's been November in 2018. Like, that's crazy.
You were almost onto something, by the way.
Really?
Me? What do you mean?
Is that yours? Okay. Old papers, these yours to keep.
Correctional erase.
Thank you.
Am I missing them?
Yikes.
I want those.
There's 12 problems, right?
Yeah.
Yeah, you got it.
What's that one?
Jordan.
That was actually close.
You tried.
Lucy.
This is from last quarter, right? It doesn't matter.
Yeah, these are from last quarter.
Why would I know?
They're the last thing you guys turned in
I'm so close.
right
Yep.
before the quarter.
I got 61.
Was this the last?
Yeah, these are last quarter.
Okay.
These are the things we turned in right before the last quarter. Darn, here, Bruce, here.
She was at Yale though.
There's also.
You turned in the test.
So, is there?
So that should be bad because I got back on.
Sam, I just figured Jordan, don't worry about it.
You
Jordan,
guys
look at
so
Jordan.
much.
Yeah, way better style.
Abby.
Look at this. I got 24.
All right.
But we all did that together. So
What,
we all
you need
got
just one more.
25. Jordan got worse.
3x squared plus 4x
I don't even like the
plus 1.
You can curveball me.
Ooh, is that, where is that?
Alright, put the 3 in the back instead.
What?
Put the 3 in the back
Is that New York?
instead of out front.
With a 3 in the back.
Put the 3 in the back instead of out front.
Okay.
So it's x squared plus 4x plus 3.
Well, if you were aiming for the blue,
I know that.
really,
No, I was gonna
All right.
the white one.
why would you aim for the white one? That's just, are you want it to the world burner?
Let me try for the blue.
You tried.
Yeah.
Jordan was walking with
It's a
you.
lost cause.
Wrong. Nope.
Oh, the way that you
I'm
are.
just writing it down more.
Is it 2xh plus h squared
I
plus
think you're right,
4h?
you'll already have it right now. 119 to 119 to 1414.
2xh plus h squared plus
Lucy has it.
4h.
I don't know.
Close.
I'll
Very,
probably
very
just
close.
turn around and count one.
We're not even close.
What?
Probably
Yeah.
Yeah, and I actually probably can't read upside down. because
You're
it's
very, very close.
Really?
I'm impressed you're trying to figure out a shortcut for something that is college level.
my favorite shortcut is.
Man, you're so smart. Why the 3.1?
I was just.
Same.
Simple fact, you're trying to figure out that shortcut by seeing one problem line.
I don't know, I just kind of saw it and like, oh, it'd make it a lot easier for everything.
Is he right or wrong?
You were insanely close
I
though.
was insanely close.
That's so
In fact, what you're trying to figure out that shortcut is what they teach you on the last day of calc after you wasted.
Yeah, the fact I had this kind of power in like kindergarten.
So can you just look it up online?
Why don't they teach you the shortcut first and then like tell you how it's done?
No, they never do. You have to appreciate the real math.
Because they have to make money somehow.
Exactly, because college is literally.
Alright, my
Sounds
watch
better.
broke. So sad.
Okay.
Like what I do to you. I put you through all this tough math and then.
And he's like, oh yeah, this is the shortcut after we learn it.
Well, that was missed.
My watch broke, so if you see a little metal rod that's like very
Can I
thin,
see how thin we're
Mr. God, it was
it's very
make
thin.
itself look super hard. and
Holy.
it's not.
It's supposed to like,
Exactly.
Are you
like-
sure it's
like
not?
that.
It was review.
It's not.
Did it just fall off now? Is it in your sleeve?
Literally everything we did last year, and
I
I
always
was.
beat.
Because you had the watch on.
Yeah. No. It's somewhere around here, but I don't know where it went to. But it's very small and I don't think it's.
Pull out the desk. There it is.
Where?
Right at your feet. Toe.
Tim, I'm supposed to have that.
Toe.
Toe.
Right in front of you. Right next to
Oh, okay.
you. Got it?
Well, you see, Bobby decided to take her
It was better than what Lorna Whelan did. She was like, oh my gosh, I lost a stud off the back of my earring. It was like microscopically small on a floor like this. I'm like,
Oh gosh.
she goes, I don't even know where I lost it. I'm like, so you're telling me it could be in the hallway?
Sabrina Hoover, Brandon Brown, Peyton Harley, Maddie Hines, Nick Dyer, Sam Childress, Jared Shaw, Caden Vitek, Kevin Myers, Carly Crane. Please come to the office.
Just get made again. These groups of shit. I just had some trunk. What?
Gave myself this bar and just some trout bush. And it's kind of hard.
You should have saw me over.
Why'd you mean to do that? No, I'm sorry.
Smashing between the pieces and breaking off the 30-year gold.
Alright. Let me get rid of that, sorry.
Is that thing still recording? It is. Blinking.